Okay. So the first thing I want to do before we start is try to figure out what this word means. So, look at the start here. Thermo. What does thermo mean? What word does this sound like? Thermo. Yeah.
Temperature.
Like temperature. And what does the word dynamic mean? What does dynamic mean? Changing.
Yeah.
So what do you think the word thermodynamics means?
Changing of temperature.
Yeah. So thermodynamics means the study of how temperature can change. How temperature can change. Okay. So thermodynamics is the part of physics that studies the movement of heat between different objects. So it also studies the change in pressure and volume. Okay, I think that's enough for you to write down. So thermodynamics is the study of the movement of heat and the change in pressure and volume of objects. What are you translating? Are you translating thermodynamic?
Yeah.
Okay. Okay. Mm-hmm.
I also don't like it.
Shall we continue? Yeah? Okay. Right. So, we saw yesterday we have this formula. Energy equals 3/2 PV. Remember that?
Yeah.
Oh, let's see how much you remember. Ben, why was the tree here?
Because it's 3D.
Good.
Move in
3D. Good.
Yeah.
And Summer, what was the cause of the P?
Particle.
You weren't here yesterday. Ben, what was the cause of the P? What's the reason for the P?
Oh, the reason.
Yeah.
Is for the.
It's what? Yes? Collisions. What collisions? Particles, yeah.
Particle. Oh yeah.
With what? Collision with what? Particle and... Particle on the wall.
Oh, particle.
Yeah. Yeah?
So I just say particle on the wall.
You say collision between particle and the wall. Between.
What's particle mean?
Molecule.
Molecule. Oh, particle.
Yeah.
Particle is molecule.
Yeah. A small thing. Yeah. Okay. We also have the formula PV equals NKT. So, maybe we can connect them. Yes. Yeah. PV, 3/2 PV equals E. So that means 2 over 3E equals PV. But PV equals NKT.
Small n.
Well, if it's small n, then it's N or T.
Oh, oh, oh yeah.
Yeah. So, continuing.
What's
Now,
NKT?
What type of energy was this? It was actually the total energy.
Oh.
What type of energy? It was actually the total kinetic energy. That's equal to NKT.
What is K?
Oh, sorry. Yeah, okay, you're right. Don't confuse me, Ben. Okay.
I mean, what is K?
Remember, okay, you know what? No, forget it. I'll just use the other one, it's confusing you. PV equals N or T. Better?
Oh, maybe.
Okay, so this is 2 over
Oh, I know the R is
8.31. Yeah, okay, fine. This is 2 over 3 KE equals N or T. Yes? So that means KE equals 3 over 2 N or T. Okay? So that means KE equals 3 over 2. Now I'll use this formula. N equals Na times Avogadro's. So that's 3 over 2 N over Na or T. Okay? Nearly finished.
So N
Sorry,
N per Na is equals K.
Yes. Yes. Correct. That's also called K.
K is other
The other constant. Boltzmann's constant, yeah. Anyways, don't worry about that. Don't worry about that. Ke over n, or total Ke over n.
You say K is no useful, unuseful.
It's not useful, no. That was the point I was making, yeah.
Yeah, obviously.
Now, tell me what this is. Total kinetic energy divided by the number of molecules. What is that in maths class? Think about maths class. You have a total,
Yeah.
and then you divide by how many you have.
Oh.
What's that?
Effective.
It's I don't know how to say that, but I know what's this.
Do you?
Yeah.
It's called the average. Average. If you have a total and you divide it by n, that's called the average. Yeah? No, don't do that. Don't do that. Look,
Yeah, it's,
2,
average
3,
minus-
10. 2 plus 3 plus 10 over 3. That's called the average. Yeah?
Yeah.
Okay, so total kinetic energy divided by number of molecules, this is called the average kinetic energy. Now, this is constant, yes?
Yeah.
This is constant, yes?
Yeah.
So average kinetic energy is proportional to
T.
T. Now that is a very important result. Why? Think about it. It means if the temperature is twice as big, what happens to the kinetic energy of the molecules? It's twice as big also.
Yeah.
Now,
Yeah.
if I make the temperature go from 300 Kelvin to 600 Kelvin, the kinetic energy is twice as big. But you knew this because you know that it means they move faster.
Oh,
Yeah?
Yeah.
Okay. But also interesting, if the temperature is 0, then the kinetic energy is 0. So it means if the temperature is 0 Kelvin, the molecules are not moving.
Yeah.
Yeah? So, okay. So I talk about this, and I talk about this, and I talk about this, and I talk about this. So everything I said here is just what I said here. I think it would be really good to write this down.
Okay. COLLED.
Oh, CAL, called KB. Got that? Can I scroll down? So look, let me just give you a very simple example. Very, very simple. Here's a gas. Here's the molecules. The molecules are moving around. Let's suppose the temperature is quite cold. Let's say it's only 1 Kelvin. Yeah, quite cold, okay? So if I use this formula, it means the average kinetic energy is 3 over 2 times 8.31 times 1. Okay, so that's roughly, whatever, it's roughly 12 joules. Okay? Roughly, yeah? So what that means is each of these molecules, they have about 12 joules of kinetic energy per molecule. Do you see what I'm saying? Now, do they all have 12? No. Some of them will be a little bit more, and some of them will be a little bit less. Some of them might be 12. It just means the average is 12. So for example, here, 12 plus 11 plus 13 over 3 does equal 12. You're saying that the average kinetic energy is 12 per molecule. Okay? But if this was equal to 0 Kelvin, what would be the kinetic energy average? It would be 0 joules, because this is 0. Kinetic energy is a half mv squared. That would equal 0. So therefore, v would equal 0. So the only way to have 0 is if they're all not moving. All of them not moving. If this is 0, this is 0, this is 0, this is 0, that means temperature is 0 Kelvin. Yeah. That's why you can't have minus 1 Kelvin, because the minimum is if they're all stopped, because the minimum speed is 0 meters per second. Okay. Whoops. All right. So that's what I just said at the bottom here.
Oops.
Huh? What?
WHOOP.
No, OOPS.
WHOOPS.
Yeah. WOOPS is whoops. Whoops and oops.
Oops.
They're different.
What?
They're different. They mean the same thing though. Okay, let's see.
The British use whoops.
Hmm?
The British use whoops.
Do they? I guess so. Okay, I think we'll do one more slide and then we'll finish. We'll continue next time.
We're having the class on Friday, right?
Yeah, assessment support.
It's going to be in the morning because it didn't show on our timetable.
No, I thought the assessment is after lunch.
It's maths, we're having maths after lunch.
Yeah, after maths.
What happened to the maths?
Yeah, after maths.
Okay, after maths completely.
Yeah.
Okay, so I just need to write it down so I won't forget.
Okay, look guys, good news for you. My computer's, oh no, it's not stuck. Right. Oh no, it is. Come on.
Who knew again?
Maybe. What?
Oh.
Come on.
Internet.
No, internal.
Internal.
Or internet.
Inside the
No, okay, my computer is stuck. So good news for you. We'll just finish there, okay? We'll continue next time. Please bring your laptop on Friday.
Okay. Sorry, I bring
Hmm?
I bring
On Friday.
laptop.
What's that?
I don't know, I just got that.
Apache? Okay. Oh, well, it doesn't matter. You just go home. We're finished.
See you.
See you Friday.